For case study 2, uh, question number 37, it's given that we have to set up a rainwater harvesting system and a tank to collect the water is to be dug. So this is the catchment area. The rain is will be falling here, and from here the rain goes to the tank. So this is our tank. Now this tank has a square base and has a capacity of 250 meter cube. This is the volume of the tank. And to dug out the tank, to purchase or yes, to purchase this much land to dig out the tank which has a square base, the cost of the land is 5,000 per square meter. And the cost of digging, it increases with the depth, and for the whole tank, the cost of digging is 40,000 x square, where h is the depth of the tank and x is the side of the square base. So this tank has a square base with side x and height h. Now, based on this above information, we have to answer the following questions. We have to find the total cost of digging in terms of x. So the total cost of digging in terms of x. So first of all, the cost of the land. Let's find out the cost of the land. So cost of the land is will be the cost of the square, because we have to dug this tank on that square piece of land, and the square has the area of square. So this is the side x, so area of the square is x square, and the per meter square, so area of the square base is x square. That has to be multiplied by 5,000, so that will give us the cost of the land. So this is 5,000 x square. Now we have to find the cost of digging, and it's given that for the whole tank the cost of digging it increases with the depth, and if h is the depth, then the cost of the digging is rupees 40,000 into h square. So this is 40,000 into h square. This is the cost of the tank, this tank, but this has to be all in terms of x, and for that is x, h has to be converted into x, and to convert this into x we have to make use of what is given in the question. It's given that the volume is 250 meter cube. So volume is 250 meter cube, and volume of the tank, this is a tank with a square base, and area is x square, height is h. So the volume is x square into h. So this is x square into h. So this is the tank with the base x square and height h. So x square into h is equal to 250, which gives me h is equal to 250 by x square. But we have to put in the value of h square. So this is 5,000 into x square plus 40,000 into h square is 250 x square upon x raised power 4. So this is the cost of the tank in terms of x. Now we have to find the rate of change of cost with respect to the side of the square base of the tank. That is dc by dx. We have to differentiate this with respect to x. So differentiating this with respect to x will give us 5,000 into 2 is 10,000 x, plus this is 40,000 into 250 square. Now differentiation of x raised power 4 is minus 4 upon x raised power 5. So this is negative 4 upon x raised power 5, which gives us dc by dx is equal to 10,000 x, and minus 4 into 4 is minus 16. So 1,60,000 into 250 square upon x raised power 5. This is dc by dx. Now we have to find the value of x for which the cost is minimum. So finding the value of x, and at that value the cost should be minimum, we have to find the second order derivative as well. So for first of all, let's find the value of x for minimum cost. dc by dx should be equal to 0, And let's put this equal to 0. So this is 10,000 into x minus 1,60,000 into 250 square all x raised power 5 is equal to 0. So let's take LCM here. So LCM is x raised power 5. This is 10,000 x raised power 6 minus 1,60,000 into 250 square, which is equal to 0. So this shifted to this side gives it's equal to 0. So this is 10,000 x raised power 6 is equal to 1,60,000 into 250 into 250. So these four zeros gets cancelled. So x raised power 6 is now equal to, this is 16, which can be written as 2 into 2 into 2 into 2. 250 is 5 into 5 into 2 into 5 into, this is once again 5 into 5 into 2 into 5. Okay, now x raised power 6 is 2. We have 2 raised power 6 into 5 raised power 6. So x is equal to 2 into 5, which is equal to 10. So 10 unit is the cost. So sorry, 10 is the side of the square base of the tank in meters. So this is 10 meter. And we have to make sure that when it's dug for 10 meter, the cost is minimum. So that means we have to find the second order derivative. So this is the first order derivative, and let's find out the second order derivative. That would be 10,000 minus 1,60,000 250 square. And now differentiation of x raised power 5 is negative 5, which will make it plus, and this is 5 upon x raised power 6. And this second order derivative, when x is equal to 10 is greater than 0, so that means c is minimum when x is equal to 10, because all these are positive. So the positive will give us the result greater than 0. So cost is minimum when the depth, when the side of the square base is 10 meter. Okay, now let's solve the part B as well. We have to check whether the cost function expressed in terms of x is increasing or not, where x is greater than 0. So for increasing or decreasing, so this is the part 3. So part 3 is part B. So for increasing or decreasing function f dash x, for increasing or decreasing function, f dash x should be greater than equal to 0. And for this, we have to find the value of x, and we have got the value of x. So let's find out the value of x. dc by dx is equal to 0. If we put dc by dx is equal to 0, we have already got the result here. So if this is dc by dx is equal to 0, which gives us x is equal to 10. So if you put dc by dx is equal to, this gives us x is equal to 10. And it's given in the question that x, for we have to check for x is greater than 0. For x is greater than 0, so this is 0 and this is 10. So our intervals are 0 to 10 and 10 to infinity. Now sine of dc by dx for 0 to 10. So dc by dx for 0 to 10, this is dc by dx. For 0 to 10, it will be less than, it will be negative. So for 0 to 10, this will be less than 0, and for 10 to infinity, this will be greater than 0. So for in this, the nature of function when it's 0 to 10, so 0 to 10, we can put in any value here. For 0 to 10, let's say other value is 5. So this gives us 10,000. So this gives us, for value 5, this is now 10,000 into x is 5 raised power 6 minus this is 1,60,000 into 250 square upon this is 5 raised power 5. So this is 10,000 into 5 raised power 6. So this is 5 raised power 6. And so this value is greater than 0. So this value will be negative. So this is negative. So that means here the function is the nature of the function for 0 to 10 is decreasing, and it's increasing when 10 to infinity. So this means that function c of x is neither increasing nor decreasing for x is greater than 0, because we have to check for x is greater than 0 and both these intervals are x is greater than 0. So here the function is decreasing, and in this interval for 10 to infinity the function is increasing, and for 0 to 10 the function is decreasing. So that means the function is neither increasing nor decreasing. And okay, so this solves our question number, the case study, that is question number 37. Let's move on to the last one.